told you to write them down. These are your rules for the main rules that we're going to be going over as far as derivatives. Now, of course, the dx, that means the derivative of. So the first rule, as I showed you, the derivative of a constant. The derivative of a constant is always going to be what? 0. So go ahead and write those down and keep them somewhere in your notebook because, and again, some of you may have seen these before. Heck, some of you may have even created them. I don't know. But the whole point is some of you may not have seen them before. So you need to write them down. And we're going to go through and I'm going to make them easier to remember. Okay? Because the way they're written like that, some of you may know it and some of you may not. Some of you may be like, what does that mean? Power rule we've already covered. Can everybody see it okay? Or you could turn in your book, I don't know what section this is in. It'd probably be in 3.1 or 3.2. Somebody could look in your book and tell me what page it's on. I'm looking, so y'all keep writing. I wonder if we can get it any darker in this room. Okay, they start 3.3. 3.3 starts on page 152. So I need y'all to write in your book, page 152. That's where these start. And they don't give you a whole list of them, they just break it up on every other page. So technically we're at 3.3. But what about 3.1 and 3.2, Hubert? With 3.1 and 3.2, I have been covering since that first day that we started limits. And I'm not going to get into that, but they're doing the quotient, the difference quotient in 3.1 and 3.2. I'll pick some problems out of the homework when I create the Chapter 3 homework. But right now, we're just making sure everybody understands what we're doing right now. Okay? I'm worried about the homework later. So, with the derivative rule of constants, basically any derivative, if I say f of x is equal to 2, then you tell me f prime of x is equal to 0. No matter what you get. What if I have f of x is equal to pi? F of x is equal to pi. Then you will tell me f prime of x is equal to what?
0.
0, because pi is a what?
Number.
It's a number. Okay, so any number, if you're asked to take the derivative of a number, it's going to be 0. All right? This right here tells you that you can have a constant in front of a function. This is really not important, okay? That's basically saying what we already went over. F of x is equal to 2x squared. Therefore, f prime of x is equal to 4x to the first. I took that 2 and I multiplied. Now, a lot of people say, well, what's the constant rule say? The constant rule says basically that I could bring that 2 outside and say f of x is equal to 2x squared, and I can say equal to, and then take the derivative d dx of x squared. Does everybody see what I'm doing? I'm pulling the 2 out. And then I'll say 2, and then what's the derivative of x squared? 2x, 2 minus 1, and then equals 4x to the first power, which is 4x. The power rule, I meant the constant multiple rule, we hardly ever go over, but it's basically this right here. Right there. That I can pull that constant out and I can multiply it by the derivative. We hardly ever do it because most of the time this is what we do. Okay, we go 2 times 2 and that's what we do. We don't do all this. So we don't really cover the constant rule. This is your first. We've already went over this. We've already went over this. Okay, so let's go over the sum and quotient rule, or the sum and quotient, no, not the sum rule, but basically terms, okay? So let me get rid of this. Let me click on this so I can see where the boundaries are. Okay. Wait, the 2, all right. So I need to... Now, what does the sum rule mean? That's basically saying that if you have a trinomial, polynomial, if you have a polynomial, that's this one right here. If you have a polynomial, you can basically break it up in terms. Okay, that's what it means. So let's say I give you f of x is equal to 3x squared minus 2x plus 6. Okay, I have a polynomial. Now that was a 3x to the 5th minus 2x to the 4th plus 4x to the 3rd minus 2x squared plus 6x plus 2. Doesn't matter. You can break each one of these up and take the derivative of each one, and that's your derivative. Okay, so this would be 6x to the first minus 1 times 2 is 2, x to the 1 minus 1 is 0, plus this is x to the 0, so that's x to the 1, 2, 1, 0, so that'd be what? 0. So 6x minus 2. Okay? So that's the power, the sum rule, which means that if you have a polynomial, to do the derivative of a polynomial, you just take the derivative of each what? You take the derivative of each term. Now, some of you may be saying, oh, I know that. Well, that's fine. I'm glad you created it, okay? But the reason I'm going over each one is because when we get to the difference quotient, the difference in the sum rule is the same. These two are the same. I'm not going to go over both of them. Because here I covered the difference rule. There's the difference rule right there because this is the difference. And this is the sum rule. So I basically covered it. You just do each term. Okay? So those are not big deals. We covered all of these basically the other day. Okay? Now, we're going to get basically into the meat of chapter 3. And there's the meat of chapter 3. 80% of your Unit 3 test, or Chapter 3 test, whatever you want to call it, 80% will come probably from this section right here. I haven't looked at the outline yet, but I would be willing to bet you that 80% is going to be coming from those three right there. Okay? I've been teaching calculus a while, and I can tell you this. That's usually 80% of your first calculus part of the test. So let's get to it. I'm going to erase the whole, well, I don't want to erase the whole board, but I'll just erase part of it again. Now, I'm going to put it in Hilbert terms because I'll be honest with you, when I was in calculus, the first time I saw these right here, I had no idea what they said. None. No idea. So I rewrote them. First, this is the product rule. The product rule says that if you're multiplying two terms, then you have to use the product rule. And the product rule says, first times the derivative of the second plus the second times the derivative of the first. And that's your product rule. Now, some of you may have heard other teachers do it that way. It's nothing. Okay, let me go back and re-say whatever I did not invent this. Okay, it's something that I used. Has anybody ever heard of first times the derivative of the second plus the second times the derivative of the first? Anybody? You're kidding me. You've had calculus before, right? Have you had calculus like in high school?
Yes, sir.
You never heard that before?
I haven't heard the way that you said it. I learned it with G of X.
You're kidding me. Huh.
What
How
did
about
you
anybody
say?
Pendleton?
Can you say it again?
First times the derivative of the second plus the second times the derivative of the first.
Oh, yeah.
Okay, you've heard it. How about anybody from Easley? Wait a minute, I'm supposed to pull in Miss Sterling. She didn't text me, but I'm gonna let me look to see if I don't want to leave her out. She's gonna give me a hard time if I do. What's her first name? Anybody know?
Jamie.
Jamie? There she is.
Yes.
But says she's offline. She didn't text me. I guess she's gonna watch the video. I'm gonna make sure. Let me make sure she didn't text me. No, she hadn't texted me. Okay. Okay, so what about, okay, there she is. She just emailed me. Okay, she's having sickness at her house. Watch video. Okay, so how about any of my Skype people? Anybody heard of first times the derivative of the second plus the second times the derivative of the first?
Yes, I've heard of that.
Good.
I've heard it.
Okay, good. So as you can tell, I didn't invent it. It's just something, it takes the place of all this stuff. Okay? So what do you do? Let's make up an example. Let's say f of x is equal to x plus 2 times x minus 3. Now let's do 2x. Yeah, let's just do 2x or 2x squared. All right, what is different about this one than we've seen before? It's not a polynomial. Now, you could use algebra first, turn it into a polynomial, and then do the sum or difference rule. Is that illegal? No. We're going to do some examples of that. But if you ever have, let's say you have sine and cosine, you can't just multiply cosine and cosine and get an algebraic function. So you're going to have to use the product rule, and you will use it. Those three rules down there, it's almost like, any of y'all ever play a musical instrument? What do you play?
I'm a voice maker. But,
Okay.
I play piano too.
Okay, you play the piano. Can you play any songs without music?
A couple of.
Okay, so you can play without something being in front of you. Okay, that's how you need to be with these rules, especially the last three. Okay, so if you've never had calculus before, and you try not to learn those three rules at the bottom there, you might as well go ahead and change majors because you're going to fail Calc 2 and Calc 3. All right, so make sure when we're going over this that you understand how to do those three rules without looking, without thinking. So let's go ahead and do this. First, well, I'll tell you what I'm going to do. Since I don't have posters and I'm not an innovative teacher, I'm going to do x plus 2, and then I'm going to do red, and 2x squared? Okay. All right, so here we go. First, x plus 2 times the derivative of the second, I'm going to say 2x squared prime, plus the second, the things I do for y'all, times the derivative of the first. Now, when I do the product rule in a instructional environment, in other words, when I am teaching the product rule, this is the way I do it. I put a prime there, and that prime right here, this prime means I'm fixing to take the derivative of that term.
Oh, so are you using 2x squared as g of x?
Yes.
Okay.
That's what this says. First times the derivative of the second plus the second times the derivative of the first. That's what that's saying. So here we go. Take my blue pen and I'm going to do x plus 2. What's the derivative of 2x squared?
4x.
4x. Plus red, 2x squared, times, what is the derivative of x plus 2?
1.
1. 1 plus 0, actually. But 1 plus 0 is 1. But I'm just going to put a 1 plus 0 there so you'll know what I did. I used the sum rule. That was a polynomial. This is a polynomial right here. So I just took the sum. I just took the derivative of the first one and the derivative of the second. Okay, so now I go back to my algebra. And you see, this is where your algebra comes into play. Really, this is the only calculus there is. This right here is the only calculus in this problem. The rest of it, if you do it before or if you do after, it's nothing but what? Algebra. So now we take our algebra, and I'm going to go black now. So that's going to be 4x squared plus 8x plus 2x squared. And 4x squared plus 8x plus 2x squared is 8x squared plus 8x. Or you can factor out a term, but usually when you're doing derivatives, that first answer you get, 90% of the time, that's going to be your answer. Now, yes, you could factor out 8x, and there's nothing wrong with that. But Dr. Harden, he would say, how many times your pencil hits the what? Paper. That's when something is most simplified. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. What would it be? That's 4, 5, 6, 7, 8, 9, 10. So which one is the most simplified? The first one. Any of you ever heard that before?
Yeah.
I can hear him saying that now.
Wouldn't it be 6x squared plus 8x?
Yes. Y'all like that, don't you? Y'all like finding errors with my basic math, don't you? You know what? Y'all, that's why y'all are going to fail. Each time you pick out my error, that's 5 points off your next test. Thank you. Well, anyway, if you factor out a 2x, whatever, factor out a 2x, it would still be most simplified when, there. Please tell me I didn't mess up anything else. Okay? So there is an example. Now, go back and do the algebra first. Do the algebra first. Let's erase all this. And let's do the algebra first. What do you get? Well, what are you going to use in the algebra? You're going to use your good old FOIL method. Pronounce it however you'd like. Glamzon. I meant your distributive law, sorry. So 2x squared is what? 2x times x is what? 2x to the third, Hubert. And 2x squared times 2 is what? 4x squared. What's the derivative of that first term? And what's the derivative of the second term? It's a miracle. The differential laws, the antiderivative laws, the logarithmic laws, and the exponential laws, do you have to all do them the same way? No. You do not have to do them the same way. As long as you do them in a mathematical proper way, it doesn't matter which order you do them, you're going to get the same answer. Everybody see that? I just showed you that with the, I just did, what did I do first? A while ago I did the product rule first. I did that first, and then I did algebra. The second time I did algebra, and then I did what? The sum rule. I did the sum rule. I just took the derivative of each term. Did I do them in any order? No, I did them however, but I got the same answer. All right? It's very important right now. Does anybody have any questions on what I just went over as far as the product rule? Okay, let's try another one. I hope the silence means that you understand everything, because I have no idea who knows what, and y'all are not talking to me, so I'm just assuming everybody understands.
I'm good.
1/2 x squared minus 2 times 1/4 x to the third plus 1. All right, so take a minute or two and do that one. I don't care how you do it. I don't care what methods you use. We're going to do both methods. Now, don't feel bad if you want to quit, because quitting's easy. I just sit on my book. Uh-oh, flamed appendix. Dang old hospital. Dang old cut it out. Dang old poison.
So combine, you get the solution of this problem.
Yeah.
Is it showing the derivative of f of g of x, or what's it showing?
Well, it's showing the derivative of that function. See, the function is factored. Right now, you got 6 times 9. The function is 54. Okay, f of x is equal to 54. F of x is equal to 6 times 9. Right now, we got 6 times 9. So if you wanted to see what the function is, then you would use your FOIL method first. Otherwise, if you don't want to do that, then you use the product rule and just do it in factored form. So right now you don't know what the function looks like. So you'll have to go, okay, 1/2 squared times. So this is going to be the function right here. What's 1/2 times 1/4? 1/8, Hubert. X to the what? X to the 5th. Then what? Outside, 1/2 x squared. Inside, 1/2 x to the 3rd. Then what? -2. Put in order. 1/8 x to the 5th minus 1/2 x to the 3rd plus 1/2 x squared minus 2. Now I'm going to go ahead and take my red pen and I'm just going to cross that one out. Why? Because what's the derivative of constant? 0. So now I just worry about these 3. Because this is my function. F of x is equal to, this is the function. This is the function in factored form. This is your 54. You know the number 54? This is 6 times what? 9. This is your factored form. You don't know what the function is until you put them together. Okay? So, okay, let's see if we can do this. Okay, 5 times 1/8. Might need your calculator. 5/8 x to the what?
4.
4th.
Right.
Minus 3/2 x to the what? 2nd plus 1, or I'm going to put 2/2, so 2/2 x to the 1st. And that is f prime of x. Now again, I'm not worried about simplifying. I think most of y'all can write a 1 there and take that. I don't care about that, okay? All I care about is that you understand how to do either, at this point, the sum rule, the difference rule, or the product rule, or the power rule, or the constant rule. That's what we're working on. We're working on these right here. And the product. Okay, now let's do it the other way. Let's do it by, okay, so you got a question? Anybody got a question?
So that shows the derivative function.
That's the derivative function of the function here. That's the derivative of this function right here.
So that means if you set that towards 0,
Then you would find your increasing and decreasing values. If you took your second derivative, and got 20 over 8 x to the 3rd minus 6 over 2x plus 1, that would give you your inflection points, which we're going to get to that later. Okay? All right, so everybody good with this explanation?
Wait, can we just write x though for the 2 over 2?
Say again?
Just write
Just 1 x, yeah. The final answer would be 5/8 x to the 4th minus 3/2 x squared plus x. That would be your final answer. All right, now I want you to use the product rule. First times the derivative of the second, plus the second times the derivative of the first. First, times the derivative of the second, I'm just going to put 1/4 x to the 3rd plus 1 prime. I'm going to put a red prime there. So that means I'm going to take the derivative of that. Plus the second times the derivative of the first. Okay, so I'm going to rewrite the first. 1/2 x squared minus 2. All right, somebody tell me what the derivative of this function is, or this term.
3/4 x squared.
3/4 x squared. Good. Plus 1/4 x to the third plus 1. And what's the derivative of this function?
X.
The x. Now I'm going to put a 1 here. I'm going to put a 1 here so you'll see that we took the minus 1 there and 2 times 1 over. Okay? Now we're going to use our algebra. What's 3/4 times 1/2? 3/8. Y'all with me? X to the what? 4th. Minus 6/4 x squared plus, what happens when you multiply 1 times 1/4? You get 1/4. And what happens when you do x to the first times x to the third? You get x to the third, a fourth. And then that's x squared. Plus x. Oh my gosh, we got 2x to the 4th. So we got to change that 1/4 into a what? 2/8. So what's 3/8 plus 2/8?
5.
Minus 3/2 x squared plus x. What do we get with the other one? Other method? Huh? What do we get with the previous method? Do we get the same thing?
Same thing. Yeah, we did.
Thank you. Appreciate the articulation. Thank you very much. Thank you. Who's got a question? You better ask now because we're moving on to the quotient rule. Okay, I must be doing a great job or you already know it, one of the two. The quotient rule says that if I have two terms that I'm dividing, what do I do? Well, if you want to be lobotomized, read that. But I'm going to use letters, just like I used with the first one. With the product rule. Hubie's quotient rule is denominator times numerator prime minus the numerator times the denominator prime, if I could write correctly, times the denominator prime over denominator squared. And that is our quotient rule. Quotient rule, whatever you want to call it. Denominator times the numerator prime minus the numerator times the denominator prime over the denominator squared. How many of you have seen that before?
I have.
Okay, good. Miss, who said that? Miss Rowland?
No, Castles.
Miss Castle, where have you seen this before? Have you had calculus before in college, or did you have pre-cal and a good calculus teacher in high school?
I had a good calc teacher in high school.
Oh, well, good. You need to go back and say, yo, you did a good job. He wasn't like the 7th grade teacher that Hubert had that really destroyed his life. No, I'm sorry. I'm just flashback. Okay, so I had a 7th grade teacher that somebody, I didn't do it because I wasn't around when this happened. Somebody, she was so mean that they put a fish on her engine of her car.
Oh,
Was it like Frozen or?
It wasn't after she drove about 15 miles. What does a fish on a car engine do to your car?
Makes it smell real bad.
It ruins it. You have to sell it. Why?
Does the oil get?
Because the fish oil gets into the engine, the block of the engine, and guess what? Every time you get normal operating temperature, what does that car smell like?
Fish oil?
Fish. It smells like fish. And you know what kind of car it was? A big old tank, Lincoln Continental. I can see that thing now. It was green, that pearl green, with a dark green vinyl top. Y'all know what I'm talking about? Big old long thing. It happened after I was at Southwood. I wasn't there anymore. I mean, it happened like 2 years after because the police came out there, and her car was ruined.
did anyone find out who did it? Like,
Mhm.
did she ever sue?
It was
Nobody
super
ever
good.
found out because back then you didn't have cameras in the parking lot.
That must be why they have locks on the hood now.
Yeah, exactly. You can get in and steal parts, not much less put a fish on them. But over in the
One of
desert,
our-
we used to heat our MREs up on the blocks of the Humvees. Yeah,
One
we
of
would
our
do that.
teachers parked out of the range of the camera, and somebody from my class put Joe piss in her air vents.
Put what?
Joe piss, like the deer hunt.
Oh, great. I did that at Walmart. When I worked at Walmart, we sat in the coverall section, and we'd hide in the coverall section. When people walked by, we'd spray their feet with dough scent. When they got in the car, that heat would hit those feet, and boy, it'd stink them out of their car. All right, I don't know why we do that. Anyway, quotient rule. So let's do f of x is equal to, I'm going to give you an easy one, okay? 2x plus 4 over x minus 2. Now, this one you can't do. You could do long division, but that's kind of like taking a scalding hot bath. I mean, it might be a bath, but it doesn't feel very good. Okay? If you try to do long division, you can do it mathematically and take the derivative of that function, but you're going to end up doing another product rule, or you have to do another quotient rule because you're going to have a remainder, and that remainder is going to be divided. And so I wouldn't suggest, when you're doing the quotient rule, unless you see something that cancels, I would go ahead and do the quotient rule. Okay, let me write that down because somebody's going to say, unless you see, I'm just going to put cancel, okay? If you see something that cancels, then you might want to use algebra first. But if you don't see anything to cancel, you need to use the quotient rule. Okay? I'll give you an example of one that you see something cancel. F of x is equal to x plus 2 times x minus 3 over x minus 3 times x plus 5. Well, there's no sense in doing the product rule up top and the product rule on the bottom, then doing the quotient rule. You can cancel the x minus 3's, and you could use algebra there. Another one would be something like this. F of x is equal to x squared plus x over x. Now, you would not use the quotient rule there because what could you do?
Cancel the X.
You could cancel the x's out or factor out x on top of it, however you want to do it, and then you would be just left with another one of the other rules. So you need to watch for it. But in this one, you really can't. You could factor out a 2, but it's not going to help you because it's not going to cancel. So we're going to use the quotient rule. The quotient rule says denominator times numerator prime minus brackets. Now watch it here. Denominator times numerator prime minus the numerator, which is 2x plus 4, times denominator prime. Right quick, why did I put brackets on that second section? Why did I put brackets on this second section? No, not that. You're getting there. But that's not exactly why I did it. What?
Do you remember to change the signs?
Because what do you have to do after you get this polynomial? You have to distribute that what? That negative. And that's where students get it wrong. That might have been what you were saying. I don't know. But 90% of the students that get this type of problem wrong, they forget to distribute this negative with this trinomial, binomial, whatever you get right here. So you might want to take your handy dandy highlighter and you might want to highlight that negative and these brackets, because of course there's some people that don't need the brackets. And we all know those people, they walk on what? Water. They invented calculus. So x minus 2 times, what is the derivative of 2x plus 4? 2 minus brackets 2x plus 4. What is the derivative of x minus 2? I did that on purpose so it would be easy. X minus 2 quantity squared. Now, are you really worried? Are you really concerned about the denominator on the quotient rule? Yes or no? No, you're not. Because where is all the work? In numerator. So you're focusing on the numerator. Now, when you get at the end of the problem, if you could factor out x minus 2 and cancel one of them, that's great. But you are focusing on the numerator. The denominator is not going to change unless you get to the final answer. So the denominator is not your focus. So we're going to get 2x minus 4 minus brackets 2x plus 4 over x minus 2 quantity squared. And what's 2x minus 2x? That's going to cancel. And then what's negative 4 minus 4?
Cancels.
Negative 8.
So your final answer is going to be negative 8 over x minus 2 quantity squared.
Do you have to do the product rule for the denominator? Or is that just
No,
like
the denominator is this. The denominator is going to be this no matter what.
Okay.
Now what you're thinking about doing is you're thinking about starting something inside of a property. No, you don't do that. With the denominator squared, you just leave this as it is. Unless you can what? Unless you can cancel. Unless, well, you leave until the final answer. Okay? You leave that x minus 2 quantity squared, you leave that. And the only thing that you can change that denominator is if something what? Cancels. Like if that would have been an x minus 2 on where the 8 is, then your answer would be 1 over x minus 2. You could cancel the x minus 2. That denominator is not, you don't touch it unless you cancel something.
Well, what about the step right there where it says x minus 2 parentheses and then parentheses 2x plus 4 right there? Is that what I'm talking about? With the red, you had the red brackets?
Yeah.
That step right there, could you cancel out one of the x minus 2 at the top and the x minus 2 at the bottom?
No. Because of this guy right there. You can't cancel. That's the same thing.
The one on the front.
No. You can't, because these two go together with a plus or a negative. If you've got a plus or a negative in between two terms, you can't cancel. Yeah, remember x plus 2 over 2. You can't cancel the 2's because there's a plus in the middle. Who's got a question on that one? Okay, let me check the time before somebody explodes.
It is 4:10.
Okay, we've got a few minutes. What time? 4:20? What time's class in?
4:25.
Okay, thank you. Let me make sure. Yeah. I was checking to make sure nobody else texted. I don't want to miss anybody, even though it's like, yeah.
Time
All right.
basically go.
Yeah, it's like the end of the, end of the class. Okay, so let's look at some problems. So this is a couple of basic problems. You can, this is your basic, this is your power rule, and let's see, I don't know if it's your power, it looks like power, yeah, it's just basic, okay? So let's do one or two. Let's do number 2. Number 2 says y is equal, and I care less about that, y is equal to 2t to the 4th minus 10t squared plus 13t. What is this? Is this a product rule, quotient rule, or are you just going to do each term?
Just do each term.
Just do each term. So that's going to be y prime, since we started with y, that's y prime is equal to 8t to the 3rd minus 20t plus what?
13.
Okay, you try number 4. Number 4 says h of y is equal to y to the negative 4th minus 9y to the negative 3 plus 8y to the negative 2 plus 12. All right, find that one. These are the kind of questions I'm going to ask you in your homework. Okay, but I haven't done the homework because, first of all, I looked over the first 2 sections of Chapter 3 homework, and it really sucked. So now I know, now that I've looked at the book, I'm going to have to look through 3.3 and 3.4. So don't expect a lot of questions out of 3.1 and 3.2 as far as your homework, okay? Most of your questions, I think, are going to come out of 3.3 and 3.4 when I do make the homework. So, negative 4, y to the what?
Negative.
Negative what?
Fifth.
Negative 5th. I guarantee you somebody's erasing a negative 3 right now. Okay? Positive 27, y to the negative 4th, minus 18, or 16, y to the negative 1, plus what?
3.
3. Come on.
I'm sorry, negative 3. Thank you.
Yeah.
I wanted to make y'all feel comfortable, so I've intentionally made that mistake. Negative 3, and then what happens to the 12? Now, are we done? No. As I told you before, some cultures, most cultures do not like that negative exponent. But some cultures don't care. But I'm going to go with the ones that, care, because negative 4 over what? Y to the 5th plus 27 over y to the 4th minus 16 over y to the 3rd.
So then you can see, but in infinity, it's reaching infinity. At 0.
Yeah, but we're not worried about that now.
Okay.
We're not worried. We're done with that. We're done with limits.
Okay.
But yeah, if you were doing infinity, y is approaching infinity, you get negative 0 plus 0 plus 0 is equal to 0. Okay, so what do you do when you do one like number 6? Quit or erase the radicals?
And the radicals.
Good. You're supposed to say quit, but that's okay. Yeah, just wait till you get to your job, and you can do that when you get a job. Just quit. Start a revolution. There we go. Try number 6. Now remember, radicals and calculus, they do not like each other. So rewrite it. That's why TI-89 doesn't really have a radical on it. The TI-89, you have to really search for a radical on a TI-89. Because by then they're saying, okay, these kids they got a TI-89, they're in calculus, so they don't even use the radical anymore. So I'm going to rewrite this as f of x is equal to, that says the 10 times the 5th root. For those that can't see, I'll just write it out for you. 10 5th root of x to the 3rd power, that's 5. Somebody's going to say, I can't see that. Minus the square root of x to the 7th plus 6 times the cube root of x to the 8th minus 3. And I can tell you right now, anytime you need to rewrite something, that is going to be a test question. Number 6 and number 7, those are both test questions. Why? Because what are you going to do with those denominators? You're going to leave them in the denominator? No, you're going to bring them upstairs, and that way you can use your power rule. Anytime you need to rewrite a question, that's going to be a good test question. Hint, hint. F of x is equal to 10 times x to the 3/5, exponent over index, minus x to the what? 7/2, plus 6 times, I'm sorry, not cube root, that's going to be exponent over index, 8/3. Minus 3. Okay, I'm going to be gracious to y'all. I'm going to do the 3 for you. There you go. So let's do f prime of x. Look, so what's 3/5 times 10?
6.
Good job. X to the 3/5 minus 5/5. Now I do this, I don't care what calculus I'm teaching. Whenever I go over one of these rewrite problems, I always do this because there is something about fractions that y'all really suck at. Okay? And I think it comes from one of your teachers back in elementary school or junior high that told you, oh, you can use your calculator. And that's where it starts. Okay? So I have to put this little added step here because some students go, where'd the negative 2/5 come from? That's what they say. So negative 7 over 2, x to the 7/2 minus 2/2, plus, okay, let's see, 8 times 6 is what? 48, and 48 divided by 3 is what? Is it divisible?
16.
Thank you. 16 x to the 8/3 minus what? 3/3. And I did 3 for you. So f prime of x is equal to 6x to the what? Negative 2/5 minus 7/2 x to the 5/2 plus 16 x to the 5/3. Somebody check my math, make sure I didn't screw up.
It looks fine to me.
Thank you. Appreciate the interaction.
Don't you have to put the negative exponent as a fraction though? Like
Yeah,
6.
you can move that down. Like I said, at that point, when you get to that answer, yes, you might want to move the 6. That would be x to the 2/5 on the bottom. But that's about the only thing left. But that's fine, yes. I would take either answer at that point. Believe you me, if you left a negative in the 2/5 after you did all that, and you did all that right, I'm not going to mark it wrong.
On the test though, do you like program the test as far as like would it know to take that answer or the other one?
Well, what if you challenge a question, how are you supposed to challenge a question?
You talk to you after class.
Talk to me after class. So if you see a question, no, I do not program the answers.
Okay.
I don't program the questions. I could, but then I'd have to go in and put the HTM in it, and I'm not going to do all that. So they program the answers. So if you was to put this answer on your test, who asked that question? What's your last name?
Greco?
Greco. So I know who Greco is now. Okay. If Mr. Greco, if you did this question and they marked it wrong, then you would come see me after class and say, look, it doesn't say, now, if the directions say write with positive exponents, then you don't have a leg to stand on. But if it doesn't say that, and you put that in, and it marks it wrong, then I will give you credit for it.
Okay.
Okay? I'm pretty lenient unless the directions do what?
So
Unless the directions actually say what you need to do. Right quick, and I know some of y'all are going to explode here in a few minutes. Okay, it's already time. I'm going to put more of these on. We're going to go over some more of these when you start. And I've got the next question. The next set of questions is there's your product rule and your power rule. And then the next set of questions is chain rule. So we've still got this to go over. I'm going to try to get you some homework on the first 4 or 5. And down to the quotient rule. I'm going to try to get some homework uploaded tonight. So be looking for it tonight or in the morning, okay? All right, let's go to our handy dandy. Let me turn off the order.